Good afternoon. Today we are working on math packet number 7. Our first page says the Brookville Badgers are competing in a grueling 12-mile relay race. Coach Thompson met with the 4-member team and gave them the following instructions. Martin will run 1/4 of the entire distance. The next third of the distance will be run by Ben. Corey will cover half of the remaining distance, and Jason will run the rest of the way. So the best way to do this is just looking at it visually with our bar model. Martin is going to run 1/4 of the distance. How many parts should I break my bar into? 4. And I know Martin is running 1/4. The next third, so from here to here, is we've got 3 parts left. The next third is going to be run by Ben. Corey will cover half of the remaining, and Jason will run the rest of the way. Who runs the furthest distance? If you map it out on your paper, you should be able to see it. Evelyn?
Would it be a third of a
When what? You figure it out? All right, let's look at our next page. Create a data set with 5 values that have a mean of 20, a median of 18, and a mode of 15. So what do those numbers mean? If it's the median, it means it's in the middle of all 5 numbers. If it's the mode, it means that's the one that we see the most of. And if it's a mean of 20, it means you total and then divide by 5. So you have to find the total, add them all up, divide it by 5, and you should have 20. So you're going to have a mode of 15. So the number that you see the most number of times is 15. Your middle number of all 5. So we're going to have 5 numbers. Your middle, that median, is 18. And if you add all 5 numbers up and divide it by 5, you get 20. So figure out if our mode is 15, I'm going to want to see 2 15s. I'm going to need to figure out what my last 2 numbers need to be to get a mean of 20. Okay, so you're going to have to work that out and see if you can figure out those last 2 numbers. Our next page is that 5-card challenge. All of your equations must equal the 9. I have had some of us having some fun with exponents. Okay. If you use numbers for exponents, it counts as a point for each one number that's being used. Keep in mind, in order to use the square root, you must have a 2 to find the square root of a number. So some of us got confused on ones in the past where there was a 2 and they had 2 and the square root. You can only use that 2 one time. So this one doesn't have a 2, so we don't have to worry about it, but just something to keep in mind if we do have a 2 in there, that you have to have a 2 in order to do the square root. But you can use these numbers as exponents. So I like how some of us are kind of exploring our number sense and finding those bigger numbers. All right, our pattern page. Pre Algebra needs to complete the entire table. So our first figure, how many yellows do we see?
1.
How many reds are there? 0 reds. So how many total blocks are there? 1. That was the easy one. Our second figure, how many yellows are there?
1.
How many reds are there?
8.
8. There's 1, 2, 3, 4, 5, 6, 7, 8. So how many total? 9. Yeah. Look at figure 3. How many yellows are there?
1.
How many reds?
24.
How many total?
25.
Now let's look at figure 4. How many yellows?
1.
How many reds?
48.
How many
49.
altogether?
49.
So now we have to see what patterns we can figure out. I would really, really hope that we all can see the pattern for the yellow.
Yeah. I can't.
So we know the yellow. Look at our total blocks. Does anybody notice anything having to do with my favorite kind of number?
What? Odd.
Look at the total number of blocks.
No, odd.
Alexis, do you know what my favorite kind of numbers are? Not odd. Tatum? Not square roots, but perfect squares. So if we look at 1, that's 1 squared. If we look at 9, what is it? 3 squared. 25 is,
squared.
and 49 is.
7 squared.
Do you see a pattern there?
Yes. Yes.
So look at that total blocks. Look at what kind of pattern you can see with my favorite number of those perfect squares. You're going to complete that pattern for the total blocks. If you know the yellow blocks and you know the total blocks, can you figure out what the red blocks are?
Yeah.
Okay, so my favorite numbers, those perfect squares, pop up a lot when we do these patterns. So always be thinking, what kind of pattern do I see? Sometimes it's easy patterns. Oh, it's every 2. I'm skip counting by 2s. But right now, we can see those perfect squares of our odd numbers. So continue those patterns. Our next page, we need to know some formulas. Now it says draw a net of the figure. And when I looked it up, because I was trying to figure out how to lay a sphere flat online, it says you can't do a perfect net of a sphere. So we do not have to do that this time.
Wait.
Because you can't lay it flat. And a net is the shape laid out flat. In a sphere, because it's all rounded, it will not lay flat. Online it said you can't do it, so we're not going to do it. So we need to know the formula for the surface area of a sphere. So write down your formula. It is 4 times pi times r squared. So if you look over at your sphere, it's telling you what r is. That radius is 9. So you're going to plug that in. So 4 pi r squared means you are multiplying all of those together. So in order to show your work, you're going to want to write it with all the numbers that you are putting into your calculator so I know what you are multiplying.
Do we write the whole thing?
You write the answer on the surface area.
Would be.
That is not. Oh, because I did it with 3.14. Round to the 100th place. So you would round to the 100th place. Our next page, we have a new formula to write down. The volume of a sphere. So volume of the sphere equals 4/3 times pi times r cubed. So one thing to think about, friends, when we have a fraction, is it easy to put a fraction into your calculator? You can't put it in as a fraction. How do we do it, Gus?
Put in parentheses 4 divided by 3.
Yeah, 4 divided by 3. Doesn't even have to be in parentheses. You could just do 4 divided by 3 times pi times r cubed. You could do parentheses, and that's fine. But just know that fraction bar means divide. So you don't have to turn it into a mixed number. You don't have to try to figure out how to write a fraction. You just do 4 divided by 3. Yes?
Even though 3.14 is pi and I put pi, is why did it come out with a
So 3.14 is rounded. Pi, if you use the pi button on your calculator, it goes on forever.
yeah.
So you have all of those decimal places that get factored in. So it's going to be a slightly different number than if you did 3.14 because you have all those decimal places. So it's going to be close, and I'm going to write down each way. So some of us do 3.14, some of us do the pi button. So I'll know what the two different numbers are, and you'll still get credit for it. So the calculation that you're doing is 4/3 times 3.14 or pi times that same radius of 9 cubed. Put the answer here. Then we have to do the pre-algebra. Now this was the part that has tricked a few of us up. A rubber sphere with a radius of 3 centimeters is put inside the original sphere. What percentage of the original sphere's volume remains available? So you need to find the volume of the rubber sphere and figure out how much of your original sphere remains available. So when you find out your radius, or you find out your volume of that rubber sphere, that's going to be like this big inside. How much of that sphere is still available, is still open? So you're going to find your volume of the small rubber ball, and then what are we going to do to the original volume? Are we going to add it to it? Or are we going to? We're going to subtract it out. So subtract out that small rubber ball so you know what's left. And that answer goes down here. Next page. We need to find the area of the figure. That is the full rectangle. What is the area of a rectangle? It is length times width. Length times width. Then we need to find the area of the shaded region. In order to find the area of the shaded region, we need to subtract out the white circle and subtract out the white square. So we need to find the area of that white circle and the area of the white square so we can subtract it from our original shape. Then we are left with just the shaded region. Remember, to find the area of a circle, it is pi r squared. Find the area of a square, it is length times width, or side times side. Pi times r squared. So you need to find those two areas and subtract it from the original area to see what you're left with that is shaded. Our next page is Fibonacci numbers. So Fibonacci numbers is you add up the two numbers before to get your next number. So 1 plus nothing is 1. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. And you're going to continue that pattern till the end of the lines. So we're going to be using these Fibonacci numbers more, just like we were using Pascal in previous packets. Now we're looking at Fibonacci. So you're going to figure out that Fibonacci pattern and just fill them in. Just adding the two numbers before to get the next number. Add your two numbers to get your next number. So it's not too complicated this time around. Polynomials, we know how to do. And our last page, reading our circle graph. So there were a total of 400 sales. We need to calculate how many sales each salesperson had, rounding to the nearest whole. So we know what percentage they had. We know what the total was. We need to find out what their part was. Remember our formula that we used. The part equals the percent times the whole. So we've got percentages. We know our whole is 400. So you're going to tell me, how much did Dodsworth actually sell? How much did Suyama actually sell? So I will tell you this. that Dodsworth's blue is the 27%. Okay, because some of these blues look similar. So the Dodsworth is this one, the 27%.
Can you, instead of writing the names out below, can you just write it next
I wrote it right next to it. That's why I put my lines over here. That's totally fine to write how much they sold right next to it. And what I did was the first thing I did was I matched up my percentages and I put it right next to their name. So I knew their percent with their name. Do your formula and tell me what part they sold. At the end, you're going to want to count it up and make sure that if you total all of them, if you add all of them, you get 400. And that is it with math packet number 7. So if you are watching this at home, we hope you are well, and we hope you have a wonderful day.